Okay, this is the P4 paper from October 2022. It's question number 4, and it's a binomial expansion question. For part A, we've got that gx is equal to that function there, and they want us to expand it up to the first 4 non-zero terms. Okay, we can do that, but first of all, we need to change the function we've got there. 4 minus x squared square root would be to the power of a half, and 1 over square root is to the power of minus a half. So now, with this thing here, I can't do it if I've got a 4 there. I want to have a 1 in my bracket there. So divide everything by 4, which would give me 1 minus x squared over 4 to the minus a half. When you're taking that 4 out of the bracket, then remember you're taking out 4 to the minus a half out. I don't think that really catches too many people out. If you can do this question, then you can certainly do that part of it. Tidy that up. 4 to the minus a half is a half. So I've got 1 minus x squared over 4 all to the power of minus a quarter. So it's now this part here that I'm going to think about the binomial expansion for. So if I'm going to do that, we're going to use 1 plus x all to the n is 1 plus nx plus n minus 1 x squared over 2 factorial plus, and we might as well put the next one in simply because that's as far as we've got to go. So that would be n minus 1, n minus 2, x cubed all over 3 factorial. Okay, so if we're going to be using this function then, just be aware of the fact that that half will have to come back in later, but I'm going to say 1 minus x squared over 4 all to the power of minus quarter then is equal to 1 plus nx, well nx is minus a half, and the sort of x here is minus x squared over 4, plus n minus 1, so that's minus a half minus 3 over 2. X squared is the minus x squared over 4 squared all over 2 factorial. And then the last part will be n minus 1, n minus 2, our x part, cubed this time, all over 3 factorial. It goes without saying then you've got to do lots and lots of practice of this to be able to get to our correct answers when we are expanding up to that sort of stage. So that's going to give me 1. It's going to give me plus an 8th x squared. It's going to give me plus 3 over 128 x cubed, and it's going to give me 5 over 1024 x to the, oh sorry, not x, yeah, so okay, I'll keep this in, I won't delete this when we're checking through then. So as we're checking through, I do various different things. So one of the things I do is I check the minuses. Minus and a minus cancel out there. The minus, and the minus squareds cancel out there. The minus, and the minus cubed all cancel out there. So yes, they should all be plus terms. The next thing I do is I actually look at where I've made my mistake here. I look at the powers, and I would say, as I have done wrong here, that one's x squared, that one's x squared squared, so that should be x to the 4. The other one is going to be x squared cubed, that's going to be x to the 6. And then when you're doing the numbers, I do it more than once. So I do, half times a quarter, which is an 1/8. I do a half, 3 over 2. Be careful there. Okay, that's a quarter squared and divided by the 2 factorial. So each time as you're doing it to try and get the coefficient, actually multiplying those together, dividing it by 6, that's what 3 factorial is. Remembering that that's a quarter cubed there. It's probably worth you doing it twice. If you get the same answer both times, then I think it's been worthwhile as a check there. Remember, as we said previously, I've got to multiply that by a half now. So actually the bit that I wanted, which was 1 over square root of 4 minus x squared is actually a half of all of that. So it's a half. It's 1 over 16 x squared. It's 3 over 256 x to the 4. And it's 5 over 2048 x to the 6. When you're doing your revision, you cannot do too many of these in terms of just making sure we can try and get those done accurately, efficiently, and quickly when we're looking at them. Okay, what does part B say? Part B says state the range of values of x for which the expansion is valid. That's always a nice easy part to actually do. So part B here, I've actually got then for this particular one that modulus x squared over 4 has to be less than 1. The thing that I'm adding or taking away from the 1 in my expansion. So in this case, that means that x squared has to be less than 4, which means that x has to be less than 2. So relatively straightforward part to that. And then part C, they're asking us to now use this, and what they're saying, use the expansion to find a rational approximation for root 3. So I've got to look at root 4 minus x squared and think, how can I get root 3 from that? Well, I can get that by simply saying if x is equal to 1. If x is equal to 1, we get 4 minus 1, which is 3, so we'll get root 3 from that. Okay, so if that's true, then when I'm doing it, go back to what we had originally, we've got 1 over, so 1 over root 4 minus x squared is going to give me 1 over root 3. So when I get my answer here, which I'm going to get by putting 1 in, 1 plus 1 squared over 16 plus 1, oh sorry, there's 3 lots of that, isn't it? Plus 3 lots of 1 to the 4 over 256 and plus 5 lots of 1 to the 6 all over 2048. Let's actually concentrate on getting that and seeing what that works out to be. But once I do get that value, whatever it works out to be, we need to remember then that that will be 1 over root 3. So 1 over root 3 is, just stick that to the calculator, 1 plus a 16 plus 3, 256 and 5, 2048. That comes out to be 1181 over 2048 according to the calculator. So then root 3 is going to be equal to that, just flipped upside down. So 2048 all over 1181. What did they ask it for? Fully simplified rational approximation. Yeah, so that's simplified down. Stick it into the calculator, just check that it doesn't cancel down to anything, but nothing goes into both of those. So that's the answer for question number 4. Hopefully that all makes sense.